Hello, my name is ALINA. Welcome to my course entitled Fundamental Concepts in the Architecture of an Electric Vehicle. Today we will move on with Module 5, Case Studies from Automotive Companies. In this module, technical personnel working in automotive maintenance and repair industry will get familiar with several components and systems mentioned in the previous modules and their specificity from one manufacturing to another. Hybrid electric vehicles equipped with high voltage components differ in practical terms in comparison with theoretical notions. This is why we selected well-known brands in HEVs such as Toyota, BMW, Mercedes-Benz, Nissan for a better practical understanding of the aforementioned general components. After reading this module, you should be able to understand the components of Toyota Prius e-drive system, understand the inverter components for Toyota Prius 3, Auris and Lexus CT, identify the HV cooling system components, understand the Li-ion battery components for Mercedes-Benz and BMW, understand the Li-ion battery components for Nissan Leaf. Keywords: e-drive, inverter, HV cooling system, Li-ion battery, integrated motor generator, service disconnect. These are all notions that you should be able to understand and use anytime you need. So, we will start with Toyota Prius e-drive system. As you can see, there is a schematical sketch of a Prius e-drive system that is made up of auxiliary battery, HV battery and relays block, HV cable, ECU hybrid control, engine, ECU, MG1, MG2 hybrid transfer box, DC-DC inverter and MGU ECU converter, AC compressor with motor, and internal combustion engine. I am sure by now you are all aware of the initials like ECU electronic control unit, HV high voltage, MG motor generator, DC direct current, and so on. In this map you can see all the components of the Toyota Prius e-drive system. Position selector sensor, acceleration pedal position sensor, HV cooling components, engine, brake actuator, wheel speed sensors, ECU motor, ECU ESP, the communication channels. They all pass through the high voltage ECU. And we can also see the hybrid transmission box, AC compressor, inverter, AC inverter, boost converter, DC-DC converters, relays box to HV battery and auxiliary battery. You can see all these notions are very familiar to you, but these are as the Toyota Prius arranged them in their cars. Next, we will see the components of an inverter for Toyota Prius, Auris and Lexus. We can see here the HV battery input, MG1 output and MG2 output. In this slide you can see all the components explained. I am sure that by now you all know these components from the other modules, but if you don't, please take another look at it and learn them very well. HV cooling system components. In this chapter, I want you to see the difference between the HV cooling system in Toyota Prius, as you can see in this image, and the cooling components of a Porsche Volkswagen. You can see the two manufacturers have HV cooling systems that differ very much. For example, the Porsche cooling system, it's much more complex than Toyota's. We can see here all the main components and what they do. Please take a very good look at them and try to understand. The lithium battery components for Mercedes-Benz and BMW. As you can see, and as you might remember, a lithium battery component is very important, and a battery pack is usually formed from cells, modules, and so on. We can see the 12 volts connection with battery management ECU, connection with coolant agent, HV electric connection to the DC-DC converter, protection relay, ventilation support with ventilation membrane and disc, HV battery module, HV battery, ECU battery management, BMS, one of the most important component in an electrical car. Lithium battery components for Nissan Leaf. As you can see, another comparison between three important manufacturers, Mercedes-Benz, BMW and Nissan Leaf. Of course, that as you may know, the R&D departments of BMW and Mercedes-Benz work together in electric components, and this is why they use the same lithium battery. But as you can see here, Nissan Leaf, another big manufacturer, decided to go with another kind of lithium battery, and here you can see exactly the components. Lithium battery, service disconnection, front right battery pack, battery temperature sensor, main relays box, front left battery pack, battery temperature sensors, lithium battery computer, back battery pack, battery sensors in the center and on the right. Here is how to disconnect the HV system. It is very important, as you may know from module 1, that the most important thing before starting to work on an electric vehicle is to disconnect the entire high voltage system. So remove the service connector of the vehicle and store it in a safe place in order to start work on your operation and repairs or maintenance or whatever you have to do. Good job! You completed module 5. After reading this module, you can observe and understand the differences between theoretical and practical high voltage components. Every manufacturer has adjusted the general principle of HV components to better suit its purpose and to offer a competitive HEV that will ensure profits and a good place on the EHV market. Here is a little assessment for you and the answering keys. Thank you very much for watching this presentation. I really hope it was helpful to you, and see you next time for module number 6. Goodbye!